Hi everyone. Today we're going to do integration, and please make sure you revise your Maths 1 standard integrals. In Maths 1, you're only dealing with standard integrals using the formula sheet of standard integration. Yeah? So now in Maths 2, we're starting to focus on the technique of integration. Yeah? So the first type of integration we're going to look at, first section, it's integration by parts. Integration by parts. Integration by parts is given by this formula, integral of u dv equal to uv minus integral of v du. Yeah? Okay, we're going to use this formula to evaluate our integrals there. But please, before you attempt integration by parts, I suggest go and revise your Maths 1 standard integrals. Because Maths 2 is built from Maths 1, okay? So now we're starting by integration by parts. So integration by parts is usually used to integrate the product of two functions. For example, we're going to use this formula. I'll show you how you can use this formula. And this formula will be given during the test, or if you're writing an exam in a formula sheet, you'll find this formula. Okay. For example, let's say we're going to start with this example. We want to integrate x squared times ln x, okay, x squared times ln x. You see, to evaluate this integral, you can't use your Maths 1 standard integrals. There's no standard formula to evaluate these integrals. You don't have a product of x squared times ln x. But because now you know integration by parts is used to evaluate the integrals of a product of two functions. We can use now this formula, which is the integration by parts, to evaluate such integrals. Okay, so okay, how to use this formula? You need to choose what is u from this function and what will be dv. Yeah, okay, so let me write this name. Always help me to choose what will be u and what will be dv. Yeah, I always use this name, Liet. Each letter stands for each type of function that you know. For example, let's start with L. L stands for log functions. Log functions. For example, log of base 2x. Okay, this is a log function. And then we have I. I stand for inverse functions. For example, you know you have hyperbolic inverse. So let's hyperbolic inverse of sine inverse maybe of x squared plus 1. This is a hyperbolic inverse function. We can also have an inverse of trig functions. For example, let's take this tan inverse of x to the power of 3. Okay, so I stand for inverse function. It can be hyperbolic functions or trig functions. Any functions that is inverse function. Okay, I stand for those types of functions. And then we have A. A stand for algebraic functions. algebraic functions. So these functions, it can be a parabola. This is algebraic functions, or square roots of x squared plus 1. This is still an algebraic function, or it can be a rational function, like 3x plus 1 over 4x plus 2x. This function over function is still an algebraic function, or square roots of a function, like square roots of a hyperbolic function is still a algebraic function, or it can be a polynomial, x squared plus 2x. In this case, this is just a parabola, okay? It can be a cubic graph. All those types of functions are algebraic functions. And then next lecture is T. T stands for trig function. Trig functions, you know, trig function. It can be sine of x, cos of x, all this trig function that you know. And I guess now you know the last letter. What does it stand for? E. E stands for exponential functions. Exponential functions, like e to the 2x, or it can be 2 to the power of 3x plus 1. These are the exponential functions. Okay, how, well, I'm saying to you, we use this name to choose what will be u and dv from this formula in our given integral. Okay, let's use this name here. We want to use this formula now to integrate our function. So, okay, let me rewrite this formula down here because of its space. Let's do a solution to this one. I want to integrate this. You have an idea. I'm going to use integration by part. Start by always writing a formula. Take a formula from the formula sheet. Integral of u dv equal to uv minus integral of v du. Okay. So, okay, I'm going to use this formula now. So I need to choose what will be u and what will be dv. So I'm using this name dx, okay, to choose what is u and what is dv. So u will be a type of function here that comes first in the order of this name. I'm saying you choose what is u here from this function that you want to integrate. U will be type of a function that comes first in the order of this name. In the order of this name. So you see, you have an algebraic function and the log function. You see, log function come first before algebraic function. So I'm saying you let u to be the first function that comes first in the order of this name. So I will let u to be a log function. In this case, our log function is ln x. Because log comes first, and then x squared is algebraic, so the rest will be just dv. I let u to be my ln x, and then dv will be the rest. So dv so will be x squared. Always when you take dv, take with the x. Dv goes with the x. So that's how you choose u and dv. After you choose u and dv, from u, find du. So du is a derivative of ln x. So the derivative of ln x is 1 over x. And then always dv and du go with the x. Always introduce dx after you derive du. Because you derive in du over dx, So this dx we cross multiply, that's why we have this dx here. So always when you're finding du, derive this function and multiply by dx, because du and dv, always don't make this mistake. You introduce dx after you put du, okay? So from u, find du. Du is the derivative of this function. The derivative of ln x is 1 over x, and then put dx. And then from dv, find v. V is just the integral of this. It's the integral of this function. So the integral of x squared is x to the power of 3 over 3. Yeah? Don't say plus c. You're going to say plus c at the end of integrating. Okay? So we choose u and dv, and then from u we find du, and from dv we find v by integrating this function. Okay. After finding all this, u and dv and du and v, you're ready to use this integral formula to evaluate this. So you're gonna substitute everything into your formula, okay, to evaluate your integral. Okay, let's do that. Let me rewrite this. We want to integrate x squared times ln x. Let's write that. Okay, we want to integrate x squared times ln x dx. We said this is u and this is dv. Yeah? So if this is u and dv, it now follow integration by parts formula. Okay, so if u and this is dv, so it will be equal to u v minus integral of v du. Okay, we just substitute our formula. We write this starting by writing our formula. Because this is u and this is dv, okay, so it means this now follow integration by parts formula, which is this one. That's why I write this formula. So the next step is just substitute everything into my formula. Okay, u times v, u is ln x multiplied by v. Yeah? So this is a product of u times v, x to the power of 3 over 3 times ln x. U times v is this one, minus integral of v. If we check v, v is x to the power of 3 over 3 times du. Our du is 1 over x dx. Okay. Okay. So the next step is just to evaluate this second term integral. It's always going to be easier to integrate the second term. Let's see. X to the power of 3 over 3 ln x minus, we can take 1 over 3 out, and integral. So x to the power of 3 divided by x, it's x squared, dx. So you see now it's easy to integrate this. So let's return the first term. Minus 1 over 3. Let's integrate this. This is x to the power of 3 over 3. And then you say plus c. Yeah? So this is your final answer, right? You're done. So the integral of this function product using this formula of integration by parts is going to be this one. Yeah? Or you can just write your last step if you like. Just multiply this 1 over 3 times this 1 over 3. Let's return this term, first term, minus 1 over 9 x to the power of 3 plus c. So this is the answer. This is the integral of x squared times ln x with respect to x. Okay. Yeah, now I think you get what is integration by parts, and then we're just gonna focus on using this formula to evaluating our problems. Okay, let's do second problem. Example 2. Example 2. integrates x times e to the minus 4x dx. Again, you see you're integrating a product of two functions. Okay. Don't confuse this with the standard integral from H1. Let me remind you the standard integral. Exponential standard integral. When we integrate f prime e to the f of x dx, the integral of this according to this formula is e to the f of x plus c. Okay. When we're integrating f prime e to the f of x dx, the integral is e to the f of x plus c. Okay. Basically, this standard integral saying if you're integrating e, that is to the power of f of x, and this f of x, if it have a derivative here, the integral is just gonna be e to the f of x plus c. If you check here, you have a function here. You don't know if it's f prime. You always need to check your power function just to check if you can able to use the standard integral. So the derivative of this is minus 4. You don't have minus 4 here, and you have a x, so you can't use the standard integral. Okay, so always when you're approaching integration, because the question would say integrate only, it's for you to check if this exercise needs match one or integration by parts, or we're still going to learn other technique of integration, or next section it will be integration by completing the square and product of trigonometric functions and powers of trig and cos function, and partial integration by partial. All these integral problems, the question will only say integrate. So it's up to you to think which technique you're going to apply to evaluate that integral. Okay. So as you can see that you always welcome to start with thinking of Math 1 standard integral. So you see you can't apply this because we don't have a derivative of this function. So now, okay, again, this is x times e to the minus 4x. It's a product of two functions. What does it tell you? You can use this integration by parts because we're integrating the product. So once you have an idea that you can use integration by parts, you always straight take a formula from a formula sheet. Integral of u dv equal to uv minus integral of v du. Okay. Write the formula first because we're going to use this formula to evaluate the integral. From this formula, you need to choose what is u and what is dv here. So I write this name again, Liet. I check here, I have algebraic and exponential. Algebraic comes first before exponential function. So my algebraic function will be u. So I will let u to be x, and then dv will be the rest, which is e to the minus 4x, and dv, remember, go with dx. That's how you choose u and dv. You choose u and dv. Because we want to use this formula, it also needs v, which we're going to find from dv, and also du, which come from u. So after you choose u and dv, what I'm saying, from u, find du. So du is just a derivative of this. It's 1, but always go with dx. Du and dv go with dx actually. And so once we have du, remember to put dx. And then from dv, find v. It's just the integration of this. Integral of v is going to be e to the minus 4x over minus 4. Okay, don't say plus c here. So I use maths 1 standard integral. So I check my derivative of the inner function. It's minus 4. I don't have minus 4. It's a constant here. I can introduce minus 4 and divide it by minus 4. So that's minus 4, or that's I divided by it's this one. And then the other one, it's a matter of integral. The integral of that form would be e to the f of x. That's why we have e to the minus 4x plus c. But yeah, but use this formula. I assume you know your maths 1. F prime e to the f of x is equal to e to the f of x plus c. So you use this formula to confirm that v is equal to e to the minus 4x over 4. I said we find v by integrating this function. So integrate this function, use this formula. This is maths 1. I got the answer. The answer should be e to the minus 4x over minus 4. All right. So after you're finding u and dv and du and v, you're ready to use the integral by parts formula to evaluate your problem. Remember, we want to integrate x e to the minus 4x dx. We said this is u and this is dv. So this is u and this is dv. So now it's follow integration by part uv minus integral of v du. Because this is u and this is dv, so it will also gonna be equal to uv minus integral of v du. Okay. So the next step is just substitute everything into your formula. When I'm substituting, it will be u times v. This is u multiplied by v. It's going to be minus x e to the minus 4x over 4. X times e to the minus 4x over minus 4. This is my first step. Minus integral of v. My v is minus e to the minus 4x over 4. But this minus will make this positive. And then times du. Du is dx. Okay, so now we're able to integrate this. This is minus x e to the minus 4x over 4 plus 1 over 4. We want to integrate e to the minus 4x dx. Again, can use the maths 1 standard integral. This standard integral formula. This one. This formula. Okay. I hope you can see it here. This formula, right, to integrate your second term. Okay. You use this maths 1 standard integral to evaluate your second term. So the integral will be, okay, let's return the first term over 4. And here 1 over 4. Integral of this is e to the minus 4x over minus 4 plus c. So when the derivative of the inner function it's a constant, just integrate your function that you know, outer function e to the function. Direct integral of e is just e, it doesn't change. But if the derivative of the inner function is a constant, just divided by this derivative, which is a constant, it's -4 always, if you don't want to use this formula, okay? So this is my answer. Okay, I can write this in my simplified form. This would be minus e to the minus 4x over 16 plus c. This is my answer, right? Okay. Next section, next problem. We also use integration by parts to evaluate the integral of inverse function and log function. For example, let's say we want to integrate ln x. What is the integral of ln x? Okay, so here we can use integration by parts to evaluate integral of log and also inverse function, because we don't have a standard integral for ln x. We know the derivative of ln x, but we don't know what is the integral of ln x. So we use integration by parts. So start by writing the formula. Integral of u dv equal to uv minus integral of v du. And then we let u to be that function, because it's one function, it's not a product. We let u to be that function you want to integrate, and then dv will be the rest, which is dx. We let u to be the function that you want to integrate, and dv, you know, it's go with dx, it will be the rest, which is dx. And then again from u, find du, which is 1 over x. Again, du go with dx. And then from dv, find v, which is x. We're integrating x to the power of 0. There's 1 here. So it's going to be x to the power of 0 plus 1 over 1, okay, which is x. Don't say plus c, you're going to write plus c constant at the end of integrating. After you're finding u, dv, du, and v, you're ready to use this formula, okay, of integration by parts, this one. So we evaluate the integral of ln x. This, we said this is u and this is dv. It now follows this formula. You can start by writing a formula so you don't make a mistake. V du, and then substitute everything into your formula, right? U times v, the first time it's u times v, so it should be x ln x, minus integral of v is x, times du. What is du? It's 1 over x dx. What you notice here, x cancel with x. So now we're gonna find the integral of ln x now. So okay, this is just x ln x times ln x minus integral of dx, because x cancel. So the integral of the second term, we're integrating x to the power of 0. There's 1 here, which is to the power of 0. X to the power of 0, so it'll be x to the power of 1 over 1, and then plus c. So this is an integral of ln x. The integral of ln x is x ln x minus x plus c. We found it using integration by parts. Okay. I'm just gonna continue and give you an example. This is the last example for Monday. Monday's lecture, I will cut and then I'll do another lecture on more example again on integration by parts that we covered on Tuesday. All right. So let's say we want to integrate now. Example 4. Let's say we want to evaluate this integral from 0 to 1 over 6 of sine inverse of 3x dx. Let's say we want to integrate this indefinite integral. We call it indefinite integral because we have these numbers. We call them the limits. I know you did this in Math 1. You know how to evaluate indefinite integrals. So when you evaluate indefinite integrals, you start by integrating your function. So the first step, solution, is to find the integral of your function sine inverse of 3x dx. We're going to consider this definite limit after finding integrals. So you see here, we want to integrate the inverse function. I just said integral, when we're evaluating integrals of inverse function or log function, you use integration by parts. So let's use integration by parts to evaluate this. We just start by writing the formula. Integral of u dv equal to uv minus integral of v du. What I said, we let u equal to be that log or inverse function that you want to integrate. So in this case, we're just gonna say we let u equal to sine inverse of 3x and dv will be the rest, which is dx. So from u find du, okay? From u find du, a derivative of sine inverse of 3x. Remember this formula when you're deriving sine inverse of x, it's 1 over square root of 1 minus x squared. And if I know you're going to use this formula, I'm going to give you this. Okay. So now I want to derive in sine inverse, but of a function. So we need to apply a chain rule after we use this formula, right? So the derivative of this, let's use this formula. Where there's x, I will put 3x. So the derivative of sine inverse of 3x would be 1 over square root of 1 minus 9x squared, okay? But there's an inner function, so I need to multiply by a derivative of this, which is 3, okay? Okay, this is my derivative of sine inverse of 3x. Remember to multiply by dx, okay? Du and dv go with dx. And then from dv find v. V will be integral of this. We're integrating x to the power of 0. So it's x to the power of 0 plus 1 is x to the power of 1 over 1. And then don't say plus c. You do that at the end of this. So now after you choose u and dv and find du and v, you're ready to use this integral by parts formula to evaluate your integral. Remember, we want to integrate sine inverse. We're integrating sine inverse of 3x dx. We said this is u and this is dv. So now it's follow integration by parts formula. That's by writing an integration by parts formula, which is u v minus integral of v du. Okay, so this is just u times v, u times v, it's x times sine inverse of 3x, x times sine inverse of 3x minus integral of v, if you check v, it's x, multiplied by du, this is my du, okay? Du is just 3 over square root of 1 minus 9x squared dx. Okay, that's how we use our integral by parts formula. So in my integral by parts, now we need to integrate the second term. So let's simplify it first. So this is x times sine inverse of 3x minus, we can take a constant out, we integrating x. I can write this as 1 minus 9x squared to the power of minus half. This is to the power of half. Now I took it to the numerator and I took the power of minus half. And don't forget the x. So now the integral of sine inverse of 3x is given by this. So the only thing that's left is to integrate our second term. How can we integrate the second term? You see, that's where your math 1 comes. Okay. You remember from math 1, we will focus on the second term. There is this formula. When you integrate f prime f of x, this is to the power of n dx. The integral is just f of x to the power of n plus 1 over n plus 1 plus c. Okay. I will also gonna provide this formula just in case you need to remind yourself with next one. So this formula basically say if you integrate a function that is to the power of n, and that inner function have its derivative outside there, you can just integrate in f of x. You're gonna say f to the power of n plus 1 over n plus 1. Okay, and then you say plus c. Only if the inner function have its derivative. Some they know EU substitution. U substitution, say it's same as f of x. U same as f of x. We let u to be the inner function such that it have a derivative outside. We have du outside. Okay, we let u to be the inner function such that it have a derivative outside. If we have a derivative of u outside here, then we can just say integrate u. It's gonna be u instead of x, n plus 1 over n. But this is for those who know u substitution. But just stick to this formula. This formula saying when you're integrating a function that is to the power of n and that function have its derivative, the integral is just gonna be a function to the power of n plus 1 over n plus 1. Okay. So you see we have something that is to the power of n, but we can able to use this formula if this function have its derivative outside there. So you always need to check the inner function f of x if it have f prime. Okay, right? So I want to check if I can able to use this integral formula. Okay, so what I'll do here, well, interpreted the second time. I'm not worrying about. So I'll let my f of x to be 1 minus 9x squared, my inner function f of x. Now I want to check what I have f prime. I'll check f prime by finding f prime here. So this is minus 18x. Okay. The derivative of this function is minus 18x. If you check here, I don't have minus 18x. I have x. Okay. So always check if f prime is short with a constant. If it's constant, you can do anything with the constant. You can always introduce the constant if you need it. If we don't need a constant, you can always pull out like this 3. We didn't need it. That's why we pull out here. So constant, you can do anything. Only if you're short with a constant, you check your f prime. You need to have f prime. So the derivative of this is minus 18x. I need minus 18x here. I'm short with minus 18, which is a constant. That's what I'm saying. It's a constant. We can introduce minus 18 here, okay? Let me let this a little bit on. Okay. Let's introduce minus 18 here. If I introduce minus 18, I also need to divide it by minus 18, okay? So because minus 18 divided by minus 18, it's 1. It's like I didn't affect the value of the integral. But I'm still, this is math 1. I'm spending so much time interpreting this second part, but it helps you to revise the math 1, okay? So the next thing now, after I introduce this minus 18, I have f prime now. I have f prime, derivative of what is inside there. I have this form now, which is f prime, f of x, that is to the power of n. What's this wrong now?